Amount of moles of electrons in 1 gram.
No. 1 gram equivalent basically means that mass which gives off 1
1
mole
mole of
electrons. You understand? The volume of solution.
Okay.
Is that clear?
Yes.
Yes or no?
Yes.
Now, how many gram equivalents have we dissolved? 800 gram equivalents we have dissolved divided by 4 liters. That's going to be the normality. So, normality is going to be here what? 20 gram equivalents per liter. Is it clear or not?
Yes.
Any doubts in this?
No.
That is a concept. Okay.
Okay.
Next question. Next question. Do this question now. Calculate the normality of a solution which contains 550 gram equivalents in 11 liters of solution. Can you do this? 550 gram equivalents in 11 liters of solution. Do it.
Yes. 50.
How? What is normality?
50.
What is normality? Given formula.
Gram equivalents over total amount of liters.
Volume. That's 550 divided by 11. So that's going to be 50 gram equivalents.
Yes.
Is that clear?
Yes.
Now that's the concept. Now, what do you mean by 1 gram equivalent, Mark? Just tell me that. This packet shall release how many moles of electrons? 1 gram equivalent shall release how many moles of electrons?
1 gram equivalent will release 1 mole of electrons.
Right. Can it also take 1 mole of electrons?
Take.
Can it take 1 mole of electrons as well?
What do you mean by take?
Like gain. One packet, can it gain 1 mole of electrons as well?
No.
It cannot gain. It can gain. See, it's like if we have a non-metal. Non-metal is nitrogen is atomic number 14. So we say that 14 grams needs 3 moles electrons to become N minus 3. So this packet, if you fill it with 14 grams, it is going to gain 3 electrons.
But it will not be a gram equivalence anymore.
Yeah, so then 14 by 3 grams if you fill in, because 3 mole electrons, to gain 3 mole electrons, you need 14 grams of nitrogen. So to gain 1 mole of electrons, you will need 14 by 3 grams of equivalents, isn't it?
Yes.
Are you understanding the point?
Yes.
So that is a concept. So it is going to be what? 14 by 3 gram equivalents per liter. Yes or no?
Yes.
So that is a concept. I hope you're understanding.
Yes.
So hence we solve this. Yes or no?
Yes.
Now tell me, Mark. Now next time if I give you the normality, if I give you the normality is equals to number of gram equivalents upon volume in liter. Okay. What else can I do? This is normality. Can I say normality into volume? Normality into volume is going to give me number of gram.
Equivalent.
Is that clear or not?
Yes.
Right? So whenever you're given the normality, let's suppose if I say 2 normal solution and such a solution I have 5 liter. What do you mean by 2 normal? That I have 2 gram equivalents per liter. One packet, 2 packets there are there per liter of, let's suppose, calcium. So that means one packet shall gain 1 mole of electrons and another packet can also gain 1 mole of electrons. So such packets are called as gram equivalents, and in such solution, what do we have? We have 2 normal, that means 2 gram equivalents per liter. Are you understanding my point?
Yes.
Do you understand?
Yes.
So how many total packets do we have in 5 liter? Every liter we have 2 gram equivalents. So in 5 liters, how do I convert 1 to 5 into 5? So I multiply this with into 5. So I will have 10 gram equivalents. Are you understanding my point or not?
Yes.
So what am I doing? I am basically multiplying 5 times 2. And 5 times 2 is nothing but 10. So normality times volume is going to be gram equivalence. Are you understanding my point or not?
Yes.
Any doubts in this?
No.
Sure? Now do this. Do this. So if I have given 4 normality, what do you understand from this? Can you read it out? That is 4 gram equivalents per liter. Are you understanding, Mark?
Yes.
Per liter of solution. Did you understand? So if I am saying that you have 4.5 normality, how would you read this loud?
4.5 gram equivalents per liter.
You understand? If we have 9 gram, if we have 9 normality, what do you mean by that?
9 gram equivalents per liter.
9 gram equivalents per liter. Is that clear?
Yes.
Any doubts in this?
No.
Right? If we have 7 normality,
7 normality. 7 gram equivalent per liter.
right? 7 gram equivalents per liter. Are you understanding my point?
Yes.
So if I say I have 8 normal solution, such a solution I have 10 liters. How many total gram equivalents do I have?
10 over 8.
Huh? You said
Total
8 normality would
8.
mean 8 gram equivalents per liter. And in 1 liter, basically, I have 8 gram
8.
equivalents. And I have such liters, 10 liters.
8.
80. 80 total gram equivalent. Is that clear?
Yes.
Any doubts in this?
No.
Yes or no?
No.
Now just see. Is that clear or not?
Yes.
So that is the concept. Now, how do I elaborate it more? So if I have normality, that is what? Gram equivalents over volume in liters. So normality is going to be what? Number of, right, given mass upon molar mass into 1000 by volume in milliliters. That is
Okay.
normality. Tell me.
Unit mass times.
Not gram, not molar mass, equivalent mass. Do you understand? Because how is that? That is basically gram equivalents divided by volume. Now, if you take the volume in milliliters, you will have to divide it with 1000. And that is given mass by equivalent mass into
Yes.
1000 divided by that is a concept.
Okay.
Okay. So that is my final formula. Did you understand? And how do you find the gram equivalent mass? That is given mass,
Over molar mass.
molar mass by n factor. Molar mass by n factor is equivalent mass.
Yes.
And that is volume in milliliter. So this n factor goes at the top. So my normality becomes equals to n factor divided by molar mass into volume in milliliters. Are you understanding?
Yes.
Yes or no?
Yes.
Any doubts in this? Just tell me.
No.
Okay? That is the concept. Did you
Can
understand
we
my
do
point?
quantum?
Sorry?
Can we do quantum?
We are already doing quantum. This has to be done thoroughly first. But did you understand this concept, Mark?
Yes.
Sure?
Yes.
So this is n factor. Got the point or not?
Yes.
Now solve the question. It says, I have taken 40 grams of HCl in 200 milliliters of solution. Calculate the normality of solution. So how do you put it? First you calculate what? You know normality is what? Given mass upon
Over molar
gram
mass. No.
equivalent mass into 1000 into volume of solution in milliliters.
Yes.
Are you understanding?
Yes.
Now what is the given mass? That's 40 into 1000. What is the gram equivalent mass?
Gram equivalent mass.
Of HCl. The given mass is 35.5 plus 1. That's going to be 36.5 over 1.
Yes.
So that's 36.5 into volume in milliliters. So volume in milliliters is 200. So this cancels. This is 200 divided by these many gram equivalents per liter. Are you understanding or not?
Yes.
Did you understand? Okay.
Yes.
That is a concept. That is a concept. Right.
Yes.
Now solve this. Solve this. Get the answer.
Mm. 5.47.
Recording in progress.
You got the answer?
Yes.
Okay. Next question. Now quickly calculate the n factor for the following terms. What is one factor? Now understand. Now today we are going to learn calculate the n factor and gram equivalent mass for the following.
I'm studying from this book, and there was no gram equivalent mass until the quantum model.
Once it comes, I'll tell you how it came. First, you do this. It says calculate the n factor and gram equivalent mass of the following expressions. Number one is H2SO4. Calculate the gram equivalent mass and n factor. Calculate this. HNO3, H3PO4. Do it, Mark, quickly. CaOH whole twice. MgOH whole twice. AlOH whole thrice. Tell me, how would you do this?
Well, I don't have the periodic table.
You don't need the periodic table. What do you want? I'll tell you the information. Ask me.
What is the... Oh, it's 2
Right. For hydrogen, the mass is 1.
gram.
For sulfur is 32. For magnesium is 24. For calcium is 40. For aluminum is 27. For oxygen is 16. For phosphorus is 31. Nitrogen is 14. Now these are the masses. Use these. How would you do this?
Two plus 32 plus 16 times 4
Right.
divided by 2. 49 gram equivalent mass.
Right.
But how many liters
Huh?
of H2SO4? How many liters of H2SO4?
No, you do not need the liters. N factor is what? N factor is what? It tells
Oh,
you.
N factor.
Right.
Okay. N factor is 2.
Right. N factor is basically that division factor which converts the molar mass into equivalent mass.
And this is 49.
Right. Very good. Because that's molar mass by N factor to give me equivalent mass. Very good. Next, HNO3. N factor is
1 plus 14 plus 16 times 3 is 63 divided by 1. N factor is 1. I cannot annotate.
you want to annotate. You have all the rights to annotate.
But it's not giving me the option. When I go to view option.
1 second. Let me see. I'm surprised. Why is that happening?
I'm having fit to window 50%, 100%,
You can annotate.
100%. Then I'm having exit, full screen, and side by side mode. Nothing else. No annotate.
I have given you the permission to annotate. You anyway solve it.
Oh, wait.
Huh.
Wait, there was a small pencil in the corner of the screen. It wasn't in the options.
Yeah.
Okay. Okay, 63. That's the gram equivalent.
Right. N factor for H3PO4.
H3PO4.
Huh.
3 plus 31 plus 16 times 4.
Right.
98.
Right.
And this is 3. 3 is the n factor.
Right. So that basically means that for 3 moles of electrons, we have 98 grams of H3PO4.
Yes. So gram equivalent mass is 33.
33? How? 98 by 3. It's not exactly 33. 32.33.
It's 32.666666.
Right. Next.
So 32.6.
Right. For CaOH whole twice, do the n factor calculation.
40.
40? How? For calcium, it is 40.
Yes.
Then?
For 16,
Right.
17
Hmm.
times 2.
That's 34
74.
over 2.
Yes. 37. 37 and the n factor is 2.
Right. For MgH whole twice.
24
Right.
plus
Uh,
17 times 58.
okay. N factor is?
Oh, 58 over 2.
Right.
So 29. And n factor is 2.
N factor is 2.
27
Right.
plus
Right.
17 times 3 is 78 divided by 3 is 26.
Right. So it's going to be what? 27 plus 34. That's going to be, n factor is 3. Oh, and that's 48.
Yes.
That's 75. And that's 75 divided by 3. So that's going to be 25. Is that clear?
Yes.
Did you understand the point? Now, do this
Yes.
question now. Now you have to solve this question fully. Calculate the number of gram equivalents of CaCO3 in 550 grams of 500 grams of CaCO3. How would you solve this?
Okay. So 1 gram equivalent is, what is the mass of Ca?
Calcium is 40.
40 plus 12 plus 16 times 3 is 100. 100 over 2 is 50.
Why 2?
So
Why
because
2?
calcium has +2 charge, no?
So,
So 2 electrons are getting moved.
and what is the charge of carbonate?
Mm, uh, I don't know.
Carbonate is -2.
So then 2 electrons will get moved.
Right. So from calcium to carbonate, 2 electrons if they get moved.
So the n factor is 50. It's 2, I mean.
Right.
The gram equivalent is 50.
No, yeah,
So
good job. Given mass,
10 packets.
that is gram equivalent. Right. Gram equivalent is 10. Given mass is 500, equivalent mass is 50. So when you cancel this 10. Is that clear or not?
Yes.
So that is the concept. Calculate the normality of 650 grams of ALOH whole thrice in 250 milliliters of solution. How would you solve this? Just tell me.
Okay, what is the mass of AL?
27.
27 plus 17 times 3, 78.
Okay.
78 divided by 3, 26.
Okay.
250 divided by 26 is 125 by 13.
Okay. What have you calculated this?
That's the answer.
That's the answer. How?
This is the normality. This is the amount of packets. 9.6153, so on.
These many packets. How? Did you do 650 divided by 26 into 1000 by 250?
Into 1000.
Because milliliters, no? So did you converted that into liters?
Oh,
Oh my.
I thought it was liters.
No. Next question. Calculate the normality of 750 grams of AL, 750 grams of in 350 milliliters of solution. And the mass of sulfur I'm telling you as 32. Oxygen is 16, H is 1. Can you solve this now, Mark?
Yes.
Okay.
2 plus 16 times 4
Huh.
plus 30. 98 divided by 2,
Huh.
49.
Right.
0.35 divided by 49 is 0.1 by 140.
What should I write down? First, tell me the formula of normality, the detailed formula.
It's wait. The gram equivalents, the liters over gram equivalents.
Right. So normality is going to be what?
Liters over gram equivalents.
Right.
And you have to convert the milliliters to liters.
Right. Solve and tell me the final answer in decimal.
1 over 140, that's the answer.
Let me solve it for you. It is 750 divided by 49.
750.
Right.
Oh, there.
So normality is going to be cancel. हेलो हाँ जी सर शुभांगी बात कर रही हूँ सर अभी मेरी बात हुई ना आपसे 2 मिनट पहले मैंने ना ग्रुप पे सारे क्वेश्चंस डाल दिए हैं एक्चुअली 2 पेपर बनाए थे मैंने तो एक में 15 क्वेश्चन थे, एक में 15 क्वेश्चन थे, तो उसमें से मेरे को कुछ 5-6 छाँटने थे, तो मैंने ना 5 क्वेश्चंस अलग से छाँट के उनके स्क्रीनशॉट डाल दिए। वो देख लिया आपने?
Are you there?
या हाँ जी, मतलब देख लीजिएगा आप, है ना, मतलब डाल दिए मैंने। ये 8वीं का, हाँ केमिस्ट्री, आप डाल दीजिए, ठीक है, ठीक है सर, ऑलराइट। नहीं, 15 क्वेश्चन तो एक ही साथ उसमें है, उसके बाद एक फोटो है और 2 फोटो है, वो देख लीजिएगा, 2-3 फोटो
43.
अलग से भेजिए, वो सारे मिला के एक 20 का क्वेश्चन का सेट बना। 20 हाँ, 8th क्लास का, हाँ ठीक है भैया, थैंक यू। ऑलराइट, सो डिड यू सॉल्व? सो व्हाट डू यू गेट?
Yes.
5 7s
43.7.
5 1s 5 5s, so it's going to be 15, and that is the answer. Did you got the point, Mark?
Yes.
Is it clear or not?
Yes. It's clear.
So that is the concept. Solve, and what is the answer? 43 point. Okay, whatever is the answer that's coming. Okay, good job. Now next is, so did we solve questions regarding mole fraction, Mark? Did
Moles.
mole fractions?
Mm,
No, we have not
I
solved.
don't know.
No, we have not solved. Now understand. Now let us suppose there is a solution, right? When in the solution we have two components. One is solute. Do we know this? And one is solvent. One is a solute and one is a solvent. Right? When one is a solute and one is a solvent, what is happening? Just tell me. When one is a solute, one is a solvent. The solute is the component present in less quantity, and solvent is that component
That's present in more quantity.
present in more quantity. So let's suppose if I have to tell that I have made a solution. So how do you
But
think
you
I
can dissolve 240 grams of sugar in 100 milliliters of water.
right? So I can say exactly. But also another way of saying this is that I'm going to mix 20 moles of solute plus 80 moles of water. So that's also,
Yes.
let's suppose the solute is sugar. So that's also one way of telling that you have mixed this much solute and this much solvent. Are you understanding?
Yes.
Is that clear? So 20 moles of solute plus 80 moles of water is going to be my answer. So what is the mole fraction? Mole fraction. If I say mole fraction of water, so that is mole fraction of sugar. Mole fraction of sugar.
Okay.
Right? So that is the moles of sugar upon moles of sugar plus moles of water.
Okay.
So basically we are trying to tell that out of the total moles that we have, out of the total moles we have in the solution, what percentage of sugar, what percentage of moles are the moles of sugar? So you have 20 moles over 20 plus 80. That means out of total 100 moles, 20 moles are that of sugar. So mole fraction. So you represent it with chi. Chi is a symbol for mole fraction. Chi is a symbol for mole fraction. Are you understanding? So that's going to be 20
Yes.
over 100, and that's going to be 0.2. Did you understand the point? Yes or no?
Yes.
Okay. So when I say the mole fraction of sugar, What exactly does that mean? Moles of sugar upon moles of sugar plus moles of water. Similarly, if I ask you to calculate the mole fraction of water, so whosoever's mole fraction you're calculating, you will write down moles of water upon moles of water plus moles of sugar. Are you understanding my point? So the answer
Yes.
is going to be moles of water is going to be 80 in this example upon moles of water is 100. Moles of water is going to be 80 plus moles of sugar is 20. So that's going to be 80 over 100. And that's going to be 0.8. Are you understanding?
Mm.
Are you understanding?
Yes.
Are you sure? Is that clear?
Well, not 100%.
See, just tell me one thing. Let's suppose you have 20 pens and 80 pencils.
Yes.
So how many total writing elements do you have? 100.
Mm.
Out of those elements, total
What?
elements, what percentage or what part of it is pencil? 20 parts. 20 parts out of 100. So mole
Mm.
fraction. That we have 2 moles. 1 moles of the solute and 1 the given moles of solvent. So we have in the solution the total moles of the solution. So when you're talking about the solution, what is the total moles? So that is the number of moles of solute.
So it's like a percentage.
Percentage, right? That out of total solution, what percent of moles are solute and what percent of moles are solvent?
Okay.
Are you understanding? So let's suppose if I
Yes.
mix 5 moles of water with 85 moles of salt. So what
Okay.
percentage of what is the mole fraction of water and what is the mole fraction of salt? So one thing you have to understand that mole fraction, we can calculate for both components. Mole fraction we can calculate for both components, for water
Oh,
as well as for the salt. Are you understanding?
yes.
Any doubts in this? So here,
No.
what is a mole fraction? So how do you represent? You write down x and you increase the length of one of the legs of x. So that becomes chi. So how do you write down chi? How do you write x like
You
this?
write X
Did you
with a
understand?
big.
Right. So that becomes chi.
Yes.
Did you understand my point?
Yes.
So this is chi. So we have the value of chi. And chi is basically moles of chi of what? Water. So whosoever is chi you're supposed to find, so moles of water upon moles of water plus moles of salt. Are you understanding? So moles of water shall be 5 over total. So this is basically representing what? Total moles of solution. But who is making the total moles of solution? The solute as well as the solvent. So we have
Solvent.
5 plus 85. So we have 5 over 90. So we have 1 5 and the 5, 5 19s. So basically 5 18s. So 1 over 18 is the chi of water. Are you understanding my point or not?
Yes.
Any doubts in this?
No.
Sure? This is the
Yes.
concept. Did you understand? Similarly, how do you find out the mole fraction of salt? That is 85 over 90. Because the total moles are 90 here.
Yes.
So we have 85 over 90. Are you understanding?
But 5 moles of water cannot dissolve 85 moles of salt.
It can. It can. Because 5
Can?
moles of water is 90 grams of water. And 90 grams of water can dissolve a lot of salt in it.
Okay.
Right? Did you understand the concept
Yes.
or not? Just tell me that.
Yes.
Okay? So next part. Let's suppose we have 800 moles of water. And I'm mixing it with 40 moles of glucose. So first of all, you tell me who is the solute and who is the solvent.
The water is the salt.
Right. And glucose is
Solute.
solute. So how do you calculate the mole fraction?
40 over 80 for the glucose and 80 over 40. No. Oh, total. 120, 40 over 120
Huh?
and 80 over 1.
1/21. Did you understand?
Yes.
Next, calculate the mole
But
fraction of water. What would be the mole fraction of water? Put in the values.
the mole fraction of water will be 80 over,
Yeah.
wait, 80 over 120.
How would you solve?
Which is 4 over 6, 2 over 3.
No, wrong. Galat. How would you solve? It is basically 800 over 800 plus 40. So that's going to be 800 over
Why is it
840.
800?
So 1 0 cancels with 1 0. So it is
How is
240
it
plus
800? It's 8.
800.
Oh, that's 800. I thought that was 80.
Why did I write 800 here then?
Mm.
Now solve.
It
Six,
looked like you wrote an 8 with an extra
now
line like this.
16 moles of calcium with 35 or 30 moles of HNO3. Calculate the mole fractions.
Okay. 16 by 46 for the calcium
Right.
and 30 by 46 for the HNO3.
Okay, good. Okay. Now solve. Calculate the mole fraction for 35 grams of HNO3. 35 moles of HNO3 with 105 moles of CaNO3 whole twice.
Okay. 35 moles of HNO3. 105 moles. 35 plus 105 is 140. So 35 over 140.
Huh. Now calculate
And
the mole fractions of both
105.
of the components and try to add the mole fractions.
What do you mean add?
The mole fraction of HNO3 comes
Add
out
the
to be 35 by 140. Am I right? The mole
yes.
fraction of CaNO3 whole twice is going to be 105 over 140. Am I right? So this is chi of
Yes.
HNO3 and this is chi of CaNO3 whole twice. So if you add them up, the denominator remains 140. So it becomes 140 over 140, which is 1.
Okay.
Which means that for a solution of two components, the sum of the mole fractions
Is always 1.
is always 1. Are you understanding?
Yes.
Any doubts in this?
No.
And hence, what is happening? Hence, what is happening?
Hence, all of the
So if I say that
so
chi of component A, a solution contains A and B.
The chi of component A plus the chi of component B
should be 1.
should, yes.
Am I right? So if one chi is 0.2, what should be the chi of another component? So 0.2, right?
Plus
Chi b
0.8.
is going to be 1, right? So chi b will be what? Chi b would be
0.8.
1 minus 0.2, and that would be 0.8.
Okay.
Did you understand? So if I give you another question, let's suppose. If I give you another question, the question says, for a solution chi of A plus chi of B is going to be 1. Chi of B is already given to you. Chi of B is given to you as 0.7. So what is chi of A?
Hmm.
Tell me.
If chi of B is 0.7, then chi of A is 0.3.
So you know that chi A plus chi B is going to be 1. So this is 0.7. So chi A we have to calculate. So chi A shall be what? 1 minus 0.7, and that is going to be 0.3. Did you understand?
Okay. Yes.
Is this concept clear or not?
Yes.
Any doubts?
No.
So we have done mole fraction today, and we have done important questions of mole fractions today. Right, Mark? So Saturday we are meeting, and Saturday we are doing more questions, right? Which is just day after tomorrow. All right?
Okay.
Okay. Bye-bye, Mark. Bye, Mark.
Bye.
हाथ से आप करें सॉरी कमा लिए 700 रुपये कुछ भी कहो इसकी वैल्यू नहीं खत्म होगी
इसमें असल में फुल टाइम नहीं है ना, तो वहाँ से ज़्यादा पैसे कमाए घर में बैठ के।
यार पता है क्या बनवा ना यू कांट पुट योर स्टेक सारे वेबसाइट
कुछ काम भी होगा, बीच में हमारा चल गया, बर्बाद हो गया। होगा तो नहीं तो अपना पूरा शक होता है।
अरे पूरा इनका ही करता रहता ना दिशाएं तो चलती है लेकिन
मैंने जो है ना नीतू बीच बीच में पूछने आता, तो मैं बिल्कुल चुप हो गई, मैं तो बिल्कुल कुछ नहीं बोलती।
इनको ये लगता है कि सामने वाले को समझ नहीं आ रहा
हाँ, ये ऐप कर रहा है, सुबह सुबह रोज पूजा करता है बैठ के। अपने बच्चे तो रोक लिए कि पेपर हो रहा है, कहीं से कुछ खिला पिला दिया कि मेरे बच्चे के सबसे अच्छे नंबर आने चाहिए। अब सब कुछ कर रहा है, पूजा पाठ।
हाँ। और वैसे इन सब चीज़ों से क्या होता है तो मैंने कहा आपने क्यों मुट्ठी पहन रखी है मैंने तो बोला ही था